Hi guys, this tutorial we're going to discuss about Dicom and how to plot the details of axial, coronal, and sagittal in Python code. Please take note, the installation of Python and virtual environment won't be discussed in this topic. So now, without any further ado, let's get started. In the next Python code in Dicom, we're going to do a cross-section to get the axial, coronal, and sagittal. For the representation, this is how we're going to slice the cross-section. Our objective here is we need to get the values of these attributes and plot it using matplotlib. So now, without any further ado, let's get started. In the last discussion, we managed to create a sample Dicom file, this one. So this time, we're going to use all the files that from the link that I gave last time. So to do that, I have prepared the image. So I need to copy those image. Oh, not this one. Okay. If you have the links before, go to that site and download one of the file so that we can use that in our example. This one, I'm going to use this patient 035. So I'm going to copy this one here and paste that in our folder, which is the image directory, and paste. I'm going to paste this one here. Okay, done. Now that we have our image, we need to open that in our Python, our VS Code. Okay, so these are the root directory of that image, and these are the Dicom files of that particular folder, which is the patient 035. Now in our next exercises, we need to create a file in Python, which is we need to do some slicing to get the plot of the axial, sagittal, and coronal. To begin with, I'm going to create a new file, which is file3.py. Okay, there you go. Now we're going to import again the PyDicom. Import PyDicom as Dicom. Next, we need to import this new package, which is called numpy as np. So since we don't have this package yet, we need to install the package in our virtual environment. So by the way, for those who did not don't understand this part here, check the first video about how to create a virtual environment. So for now, I'm going to install pip install numpy. Okay, so satisfied, numpy. Okay, good. So we have already have our numpy. The next thing we need to install is we need to call our matplotlib. So, to begin with, we need to import matplotlib.py.plot as plt. And also this time, I'm going to import the OS. If on a long run, if one of the package don't work, make sure you need to install that using pip. Okay, so now we'll be calling our path. For the path. To call that, we need to declare ./img. That's the name of the folder. Then going to assign a variable which is ct images. Now this time I'll be using OS to list down the content of this directory. So to do that, we need to type list dir path. Okay, good. Now we have the list. The next thing we need to do is we need to slice, and we need to slice and then rearrange our ordering, because by default it is scattered. Even in the once in the file, it's not really arranged. So the first thing we need to do is we need to slice this one, and then we need to sort it out. So which means we need to arrange the order. And calling the slices. Slices. But before we need to do the slices or to ordering this one, much preferred, we need to call this first using the Dicom. So to do that, we need to call or read the files using Dicom. So to do that, you need to type this one, Dicom dot read file. So and the path plus slash a. So Dicom read file. So this is one of the properties of Dicom. Path. So this is the path plus s. So s represent the file. Then we need to impose the force so that it will force read the path. Then we're going to assign the for loop or the s in ct images. Okay. Now what does is using Dicom, it will going to list down all the files. So let's check first. So we need to print these slices. Slices. Okay, that should be it. Now we need to run this file. So we need to clear everything here. Then py.file3.py. This will take long because we have a lot of files here. So hold on. We have 451 Dicom files. So in every Dicom, most of the file content is not only 100, but it depends on what kind of scanning they use. Okay, so it seems we're done. Let's go on the first part and see the result. Okay, so now we have managed to slice the information. Okay, that's good. Okay, so now this is good. Now the next thing we need to do after slicing, we need to sort this one. To do that, since we're targeting of getting the plot, next thing we need to do is we need to sort this one. To do that, we need to comment this one here. And then I need to call the slices. Then we perform the sorted, so which means we need to rearrange into alphabetical or highest lower or lowest highest. So next we need to slice this one here. Then we'll be using lambda. We need to assign the key with this lambda here. So with the value of x, and the attributes, which is the image, position, patient, 2. So in this section here, we need to get the position, the coordinates. So this is, we need to check image, position, patient. That should do it. Now, since we already have do the slicing part here, we need to check. The first thing I need to do is get the pixel spacing. To do that, I'm going to call a variable, which is pixel. Spacing. And we're going to call the slice with the index of 0. That's the first part. Then with the attributes of pixel spacing. For those who don't understand what's these attributes, check the first video series on how to know what attributes that you're going to use. Okay, so next we need to get the slice thickness. So we need to get the thickness of this word icon. See, so I need to copy this one here. And this is slice thickness. Sure the spelling is correct. Very good. So actually, these are one of the things that we need. Now, since we're going to get our axial sagittal coronal, the first thing we need to get is axial. To do that, we need to call the axial aspect ratio. So, and we're going to call the pixel slicing or spacing. Sorry. So the index of 1 slash or divided by pixel spacing. Okay, so we need to getting this formula. Let's say going to go to the index 0. Okay, so that's how we get with our axial aspect ratio. Now the next thing we need to do is we need also to get for sagittal aspect ratio. To get our sagittal aspect ratio, we need to get spacing here, copy. This time going to divide by our thickness. Okay, so that's how to get the sagittal aspect ratio. Then the next part, we need to get the coronal aspect ratio. This time, we're going to use the slices thickness. Then to get that, we need to divide that by pixel spacing. For the pixel spacing, we need to get the attribute index of 0. Okay, there you go. Now to understand this one, we need to print our output. So to do that, we need to print. First, we need to know or to display the pixel spacing. We need to check the spacing. And here, slash. Okay. To do that, we need to get the value of pixel spacing. Here. Okay. And the next one, we need to print the slices thickness. Okay. So please go on here. On this part here. Okay. Let's check first what's the output of our pixel spacing and slices thickness. Let's clear our value here. Okay. So let's go the file again. Okay. Okay, so we have an error here. Type object is not iteratable. Line 11. So let's go to the line 11. So let's check. Oh, because I use slices. Yeah, should be slices. Okay, that should work. We need to check our code. Clear and run. Okay, K is an invalid keyword for sort. So that is under line 11. Okay, let's check this here. Why is it? We have K. Oh yeah. So we need to assign this as key. So this is one of the reserved word. Okay, so make sure everything's working now. Okay, seems it's okay. So clear. Okay, so we have another error. So this time is on line 13. So another logic here is type object is not subscriptable. So let's check. Pixel spacing slash lines. It should be slices. Okay, so we're referring to this one here. Here. Hopefully no error anymore. Seems working. Okay, good. Okay, now we displayed our thickness and pixel spacing. This is how our output. Okay, good. Now, the next thing we need to do is we need to print also the three part here. So what's the output of the axial aspect ratio, sagittal, and coronal. To do that, we need to create another file section. This one is axial aspect ratio. So, colon inside, comma. Okay. And the value. This one here. Okay, next one, I need to copy this one here, and paste, and paste. The next one is sagittal aspect ratio. So it should be sagittal. And the last one is coronal. Coronal aspect ratios. This one need to replace coronal axial aspect ratio. Good. Okay, let's clear. File 3. Okay, so as of now, this is our axial ratio 1.1, sagittal aspect ratio of 0.6.9 something here, and the coronal aspect ratio of 1.44 dot something. Okay, good. Seems this one is working now. Okay, the next thing we need to do is we need to list down our image in our Dicom. So to do that, what we need to do is I need to declare an image here. So, since these are all image, I'm going to call image shape. I'm calling the list. Then we need to slice again. Or calling the slice 0 and attributes of pixel array. Pixel array. Then we need to get other properties. This one, which is the shape. Okay, next, after we list down all these things, we need to call again our image shape. And this time we need to append or add these slices as one. And we declare the length of these slices. Now, since so we need now to get the volume for this one. So let's say this is the volume 3D now. Let's say numpy is equals to zeros. Image shape. Okay. Okay, the next thing we need to do is convert this value of array into 2D array and the volume 3D. Also as a 3D image. So to do that, we need to call a for loop for I s in enumerate slices colon, and we need to get the values in array. array 2D, and these values from pixel array, also the 3D, polyvolume 3D. I need to call this here colon that with the value of the array 2D. Array 2D. Okay. Now what we need to do is we need to check our output for this one. So to do that, we need to print our array 2D. Okay. Let me check first. Okay, so we need to print this one. Print. Just to make sure that we get the correct value and the volume. Really. So now, for what particular things that we need to check? So for this one, we need to check the attributes of shapes. Shape rather. We need to copy. And also our volume 3D. Okay. I'm going to comment this here so that we'll be focusing only on the okay, now let's check. Clear Python file 3. Okay, so we have an error. So object is not subscriptable. Underline 27. Okay, so I think we need to slices. Yeah, because this is slices. Save. Hopefully no more error. This will take time because we have 451 Dicom here. We'll see if we have succeeded enumerate our values, which is the array. There you go. Okay, seems these are working. Now we're ready. Now this time, since we already have our value in array 2D and volume 3D, the next thing we need to do is we need to plot this value. To do that, the first one we need to plot is we call the axial. The axial, this time we're going to use the plot matlit here. Then with the subplot with the positions of 2, 2, and 1. Okay. So better understanding, we need to put a title. This is axial. Next, we need to show this one, which I am show. So we need to show the volume 3D. Need to assign the output. This is the position. And should be the image shape. with the index of 2 and disable. Okay. Now the next one we need to do is we need to set this axial set aspect, and we're going to call our axial aspect ratio. This axial aspect ratio, if you remember, this is the one we created here. Okay, let's try first for axial. Need to plot this one. So check here 5. Okay, there you go. So right now we have our very own first plot, which is the axial. Seems this is okay. Okay. The next thing we need to do is we need to plot this time the sagittal. All that we need to call sagittal. And with the plot subplot, so with the position of 2, 3, and 3. We need to set a title. This is Sagittal. Now we need to plot this inside that frame. To do that, same, we need to call the plot that I am show, and the volume 3D. Okay, so and the position of that is, where's this one? Image shape. So this time we're going to get the index of 1 and 2, comma. Okay, that should be okay now. Okay, so next we need to set, or we need to get to set the set aspect. So Sagittal dot set aspect. So this time I'm going to get the sagittal ratio, the value of this one. Okay, so just to make sure that we have the right value. So this is what we assign here. So, yeah. Okay. Save. Notice I keep this plot show here so that it will display all these two plot here as one. Okay, let's try. Okay, there you go. So seems our sagittal is already here. Good. So next. Okay, the next thing we need to display is maybe we need to arrange that instead of 2, we're going to put it into 3. 2. Because it's already 1. So save. Good. So I think this is a good representation. Next, what we need to do now is we need to plot also our coronal. Okay, so to do that, we need to plot coronal. And we need to plot subplot. But this time, this is 2, 2, and 3. Okay. And the plot title. This is Corona. Okay, good. Now we need to plot this in the plane. I am sure. So this volume 3D. Upon here, we need to call the image shape. This time we're going to take the index 0. Oh yeah. So this time here. And call this 3. After that, we need to call the coronal dot set aspect. We need to set the aspect. To do that, we need to call that coronal aspect ratio that we declared a while ago. Highlight so that make sure that this is the correct spelling. So it's okay. Now, need to save. So let's check. There you go. Okay, so that's it, guys. Okay, so there's so many ways how to do this. For now, this is our very own basic. So for the next chapter, we're going to explore more on how to use fully function or all those attributes that we discussed on the first part. So now we have successfully displayed or plot the axial, sagittal, and the coronal. Again, if you find this video informative, don't forget to hit the like button and subscribe. See you guys on the next video series. Cheers!